All right, legends, this is Mr. Maze coming to you through the virtual space, and today we're going to take a look at all of the pro tips that you want for Unit 1. So these are going to be the Unit 1 pro tips. Bear with me. I'm going to try and be fairly speedy to get through all these tips. Hopefully you're studying up, and I'll say this, if you know everything, you should be good to go anyway, but here are my tips. Tip number 1 for you that I'm going to throw your way is remember that if I ever phrase anything in this way, or if you see it ever phrased, right, something is blank standard deviations away from the mean, you should know for sure that phrasing, blank standard deviations away from the mean, that means we're talking about a z-score, right? Both when we express a z-score, right, when we're interpreting a z-score, and that's a key thing to remember here when I say interpret, right, solve for and interpret a z-score, you're probably going to use a sentence that starts with blank data point is blank standard deviations away from the mean. Right? And normally when we say away, we're talking to the left or to the right of the mean, but away is kind of neutral. It can mean either way. You need to be clear. If you're interpreting a z-score, you know it's blank standard deviations lower than the mean or higher than the mean or to the left or to the right of the mean. But just know that phrasing, like if you see in a question, something is 0.84 standard deviations away from the mean, that's not the standard deviation, that's the z-score. Perfect. Make sure you can turn your z-scores into percentiles and your percentiles back into z-scores. Got a little hair on my paper here. Also remember that we almost always are going to be using z-scores. We're very rarely going to be using percentiles. We might use percentiles to kind of as our solution for a problem, but very rarely is a percentile going to show up in your sort of calculation in a problem, if that makes sense. And we saw this with our setup for like z equals x minus mean over standard deviation. This is always going to be the z-score in this format. Even if it's rewritten, even if the answer, right, wants you to give it in the solution form of like the data point, where it's like z times standard deviation plus mean or whatever, no matter what, it's always going to be the z-score we see in that particular position. We're not going to be using the percentile. And remember that anytime we plug a percentile in, we're actually going to be plugging it in as an area. So we're either going to be plugging it in as a decimal with the value of the area to the left, or we're going to do 1 minus that particular decimal to get the actual thing that we're working for, right? So if I had like a normal distribution and I was like, I want to know where the top 15% of results are, or above which 15% of results lie, what I would do is I would do 100 minus 15, because we can only do area to the left. So we would be taking this and doing 100 minus and finding that, and we would get, 85th percentile from that end, and we would use 0.85, plug that into invert norm, along with a mean and standard deviation, and we'd be good to go. Okay, so we're pretty clear, hopefully, on we're going to be mostly using z-scores, and we'll be translating between percentiles and z-scores a fair bit to be able to do comparison, but normally we'll do that. Okay. And be able to recognize like the difference between two z-scores, right? Like this z-score is higher, so it means you are taller than somebody else. Or in the case of comparing z-scores for speed, right? A lower z-score means you're actually faster than somebody else, and that's going to be key. So remember that like with speed, for example, and speed is one of those weird examples, it actually means like the lower end is faster. And so smaller z-scores are actually better if you're doing a speed distribution, because the bigger the number, the bigger the time it was that it took you to do it in, the slower you were, right? And that applies very well versus like weight, like lower is less weight, so it would be worse. And be able, and I'll say that here, be able to compare z-scores effectively. And not only compare z-scores for like one z-score across two people, you might have like two people. This is person 1, and this star can be person 2 because you're all individual stars. And you might be comparing two qualities about them, right? You might be comparing like the height, excuse me, and, you might be comparing the height and how fast they are. And then if you have to do that for each person, you'll have 2 z-scores for person 1 and 2 z-scores for person 2. You'll have to interpret them correctly. Remember, speed is going to be kind of the opposite of height in the way we look at those z-scores. And you're going to have to, in context, be able to be like, oh, so-and-so is faster than this person, but this person is a lot taller than that person. And so if they're equally valuable, whichever metric is outdone overall, that's the one that ends up proving for what you want. But just something to keep in mind, because I'm definitely going to throw something tricky like that your way, maybe in the FRQs, where I have you do 2 z-scores for 2 people, and then you have to interpret those and be able to say which person is overall more successful and give a good explanation for that. Okay, let me turn over to my notes and see if I've got anything else for you. Well, I would always recommend, I'll switch over to red, I would always recommend sketch yourself a little distribution graph anytime you can. Remember the ways that we tend to write these, right? The mean, and then like mean minus a standard deviation, mean plus a standard deviation. Be able to do those like small calculations, like adding or subtracting 1, 2, 3 standard deviations from your mean to interpret, and then be able to determine like what area would be shaded for a particular distribution. If I, asked a multiple choice or an FRQ question that had you kind of interpret that, right? Oh, where would I expect the area shaded to be if it was between this number and that number? Be sure you're able to run those calculations. Remember your 68, 95, 99.7 rule that within 1 standard deviation to the left and to the right is 68% of the data. Within 2 standard deviations to the left and to the right is 95% of your data. And within 3 standard deviations to the left and to the right is 99.7% of your data. Remember in translations that centers are affected by multiplication, division, addition, and subtraction, but that ranges and spread are only impacted by multiplication and division, right? So be ready for a question where I'm like, there's a variable x, there's also a variable y such that it is like 4x minus 2, right? And then I would say, don't do that to me. Don't do that. Thank you. Okay, so let's say, and then I would say if I have a mean for x of 10 and a standard deviation for x of 3, I would say, okay, what is my new mean and my new standard deviation for y? And you should be able to sensibly be like, oh, okay, well, that would be pretty easy. My mean for y is going to be 4 times my mean for x, which in this case is 10, minus 2. But my standard deviation for y is only going to be 4 times my standard deviation for x, which is 3, right? So we would have a mean of a mean of 38, right? Because we did, multiplication and addition, subtraction, but we'd only have a spread, or I should say a standard deviation of 12, because we wouldn't employ the subtraction or the addition aspect. Okay, hopefully you're following along. I hope you get the feel. This is kind of how the pro tips go. We're a little sporadic, but again, this is to supplement, so to go alongside what you already know, just to make sure that we're all clear on the things that might be highlighted. Remember that the standard deviation, another way of talking about standard deviation, is it's the average distance of a data point, I should say, of any given data point, of an individual data point from the mean. So one standard deviation is if I were to randomly grab a data point, on average, it would be 1 standard deviation from the mean. Now, I pull a data point, it's not actually going to be 1 standard deviation from the mean. But basically, you took the distances that every single data point were from your mean, and you averaged those. So the average distance, so basically it's the mean, another way to say that is, it is the mean distance of a data point from the mean, right? So the standard deviation is the mean distance of a data point from the mean. And that's good to know, just because that phrasing is kind of ugly, but we should understand that as an idea. The standard deviation approximates, on average, how far away is a given data point from the average. Beautiful, beautiful. Guys, we're zooming. This is beautiful. Hopefully you're studying very, very hard. Know how to read a two-sided stem plot. A two-sided stem plot. I guarantee you're going to see one. Two-sided stem plot. So remember, the rule of thumb for that is low is left, or left is low, however you want to write it. So whichever end is the low end, where the lower numbers are sitting, that's the left side of the distribution. And be sure to be able to read the numbers, right? Like if I had like 3, 4, 5, for example, in this setup, and this was a 2 and this was a 1. Remember that this is 31 and this is 32. It's not 23, right? We read outward from the particular stem plot center. But just be comfortable with two-sided stem plots. I guarantee you're going to see at least one. And again, left is low. Know how mean and median respond to skew, right? So if I have a distribution that is left skewed, if only slightly, which this one is, remember that the median is going to stay with the peak versus the mean is going to drift with the skew. So the mean will be lower than the median in situations where you have a left skew, and the mean will be greater than the median in situations where you have a right skew, because the mean will follow the direction of the skew, and left is low. So left skew, lower mean. Right skew, higher mean. Good. Remember how quartiles work as well. And remember that, like, for example, when we think about quartiles, whether there's a box plot or not, remember that in quartiles, we have the same amount of data points in every quartile. So 25, 25, 25, and 25 make up those 4 sections of data. Okay, but the value of one quartile minus another will vary depending on how spread out it is, right? So if I have a box plot like this is my little hint to you because it may be helpful in a problem. There are the same number. Let me mark these out. This is Q1, this is the median, which of course we know is also Q2, and this is Q3 over here, and then this is our max, and this is our min, right? Now on this distribution, we would say that the distance from the min over to Q1, right? We would say the number, or I should say, we would say the number of data points between the min and Q1 is equal to the number of data points between Q1 and the median. We would know that. That is absolutely true. They have the same number of data points between them. However, we would also say that the value of Q1 minus the min is a greater value than the median minus Q1. And what that's saying is, if I took my quartile 1 value, I would expect a much bigger number by subtracting the min from it, because there's a greater distance of x values between the min and Q1. Same number of data points, but a greater x value, a bigger range, if you will, between min and Q1 than between Q1 and median. And I'm telling you this because you can expect either multiple choice or FRQ questions that ask, but probably multiple choice questions, that ask you about like number of data points or number of values between a certain thing versus the number being larger, right? The value between, like if I go Q1 minus the min, right? The value will be greater. That's something that you can keep your head about you with. Okay. Oh, and this is like an overarching thing. Remember to use process of elimination. You should understand every answer choice, but if you're at a point where you're like, oh crap, I'm not perfectly certain about this one, don't quit and don't just auto guess. See which ones you can eliminate, and that can bring you closer. So in statistics, especially with the MCQs, oh goodness, I don't know why I was still on the highlighter. Especially with the MCQs, I'm not saying always do process of elimination solely. But be aware that for some of the questions, process of elimination is actually the fastest way to do them for some of them. For some of them, you'll go through and be like, no, I should just solve this, right? So ones where you're doing like z-scores or comparing percentiles or trying to make a determination about like, is one greater than the other, you're probably going to do that by hand immediately. But for some of them where it's like phrasing or wording or things like that, or which one is not the case or which one is the case, process of elimination is super useful there. So if you understand which ones it's not, you're closer to which ones it is. And I'll say that as well. Read closely. And always return to the question. So when you're looking at the MCQs and you feel like you've picked your answer, return to the question and make sure it's asking for what you've been looking for. Because a lot of times I'll write like, which one is not the something, right? And so make sure you go stop in and make sure it's that versus which one is true or whatever it is I may do. Again, because I'm just trying to try out these AP methods that they use on the test to be tricky with you. And that's another thing. Remember not to be tricked, okay? These questions are trying to be tricky with you. Don't let them trick you. Read closely. Remember that you know statistics and you know how statistics is supposed to work. Don't let statistics scare you. Don't go and just auto pick an answer because you're like, that's the number I saw in the problem. Remember to think critically and think about what's being asked for and then provide what's being asked for. Okay. And I said this already, but don't use percentile in like equation work. We're probably going to be looking for a z-score there or a decimal. Know how to read a histogram, know how to read a box plot. There are going to be a fair number of MCQs looking at histograms and box plots. Just make sure you can read them, make sure you know where outliers sit. Remember that for box plots, we often use interquartile range, which we know is Q3 minus Q1. But remember also, raw range for box plots, that includes outliers. Which remember are normally either dots or stars on the graph. That includes outliers. So that's part of why we use IQR often for box plots, is because actual raw range, you have to include the outliers. And so if a question says the range of a box plot is something, it has to include the outliers in that approximate range. And side note, but very, very important, know how to do 1.5 times IQR. 1.5 times your interquartile range in order to check for outliers. So remember that equation and that setup where Q3 plus 1.5 times IQR is your upper gate. Anything that is greater than that is an outlier to the maximum side. And then remember that Q1 minus 1.5 IQR. Anything that is less than that is also an outlier. I know we know that from our mini quizzes, but just be sure you know that because I can tell you right now there are some MCQs and there's definitely an FRQ where you're going to make use of solving for outliers in that way and being able to interpret it effectively. So know that really, really, really well. We talked about box plots and histograms. Remember that z-scores are also sometimes called standardized scores. Okay, remember those are the same thing. It's just another way. Standardized scores. And remember that like they're not affected by translations. Neither of these things, they're the same thing, but they're not affected by translations. So if you change up a bunch of the data, right, if we translate the data, that's going to affect the mean by multiplying and dividing and adding and subtracting. It's going to impact the spread by multiplying and dividing only. It's not going to impact your z-scores at all. Because remember, z-scores are standardized. They're a way of taking all the data, and as long as something falls on a normal curve, it doesn't matter how it's translated, the z-score is the z-score is the z-score. And that's why they're called standardized scores, z-scores. They are like unaffected by translations of the data. So anything that doesn't like destroy the data or fundamentally alter the data is not going to impact the z-score. And that'll be useful to you, as you'll see soon. Know CSOCs. Know how to use CSOCs to describe distributions. We've done a lot of comparing distributions. Be sure you know how to use it to describe, which is just when I give you one distribution and you run through the elements of CSOCs, but know it inside out and backwards. It's likely to be a histogram or a box plot, so get it right. Remember, for histograms, this one's a key. You're often going to be using the squiggle. You're going to say approximately. So be sure you're ready with that for histograms because we don't know exactly where the values fall in bins, right? But when you do use 1.5 times IQR on a histogram to check if there are outliers, which is something you may do in particular problems, be sure to check and don't just look at the histogram and go, that looks far away, that doesn't, because you may find that something that doesn't look like an outlier on the histogram actually is one because of your calculations. So be aware of that. That's how I can be tricky and AP can be tricky. All right, we're good on z-scores. We are good on 1.5 IQR. Remember how to compare, or remember when we're like comparing two distributions or a data set in a distribution? If you're making like an overall comparison, center is king. So if I'm saying to you, hey, here's one data set with like values min, max, lower, higher, whatever, and mean and median, and then here's another data set with the distribution. Here's the visualization with it, and you can approximate the median. And I say, which one has greater values, right? you would use the median or the mean, or both, frankly, to approximate which one has overall greater value. So if I'm comparing two distributions or a data set in a distribution, remember to use center to compare overall, height, weight, whatever the measure is, overall value. That's the word I'm looking for. The overall value. So again, and this is like very obvious, but I wanted to be very clear and upfront about it. If I was to say which data set has, the greater levels of something, or which one's higher, or which one's lower, or whatever it is, you would want to say, I'm taking a look at the measures of center here. This one has a higher mean and median than that one, so on average, the values will be higher in this particular distribution or lower in this particular distribution. So just remember that center is the way to do big overarching comparisons about just the value of one thing over another. On average, this thing is lower. On average, this thing is higher. Oh, we're nearly done, Legends. Okay, let me just finish up with this. Remember your 2 to 3 standard deviations to the left and to the right of the mean? That will decide whether something is considered approximately normal, right? So if your max is between 2 standard deviations and 3 standard deviations from the mean, it must be between the value of 2 and 3. So remember how to take your mean and add a standard deviation, or add a second standard deviation, and then check between that and adding a third standard deviation. And remember that your min must lie between, right, -2 standard deviations and -3 standard deviations from the mean, between those two values. I guess I should probably flip-flop the two, -2 and -3, but you know what I'm saying, on a distribution. That's what it would look like. And if that's the case, then it's approximately normal. If not, what you would say in your answer is, because the max does not sit between blank and blank values, it does not lie between 2 and 3 standard deviations from the mean, and therefore this is not approximately normal. Or same thing for the min. Because the min does not lie between blank and blank values, it does not lie between -2 and -3 standard deviations from the mean, so it is not approximately normal. Okay? And I already said, be sure to be able to compare two particular distinct qualities about a person, for example, or about a data. Where is it? Way up here. Where is it? Mr. Maze searches. Can he find it? I don't think he can. Where did it go? Where did it say P1? There it is. Here. Remember that I'm probably going to throw something your way where you have to compare 2 z-scores across 2 different people, or 2 different animals, or 2 different particular structures we're looking at. And be sure that if you interpret them correctly, you know how to say this one's faster or slower than the other one, and overall this one's better or worse than the other one. Okay, that's been a little all over the place, but again, that's kind of the nature of the pro tips. If any of those are confusing, shoot me a remind message as you dig in further, and I can give you more details if something isn't clear. But go back through the video notes, study up through all of your notes, go through the homeworks, go through the mini quiz, and go through the review guide, and then listen to these pro tips a few times and make sure it all makes sense. I am so indefatigably proud of you. Thank you for taking this course. Thank you for endeavoring to become a master of statistics. I want to see brilliant scores on this test, and I cannot wait to see you succeed. Thank you for being my students. I'm proud of you. This is Mr. Maze signing off.